Hey there, class. We're here today. We're going to look at the different types of energy. Specifically, in this particular class, we're going to focus on something called mechanical energy. Now, mechanical energy involves basically four types that we typically deal with. That's kinetic, gravitational potential, elastic potential, and rotational kinetic energy. In this class specifically, we deal with the first three, and we don't really deal too much with rotational energy, but it does exist. Now, energy is a very broad topic. It does incorporate so many different aspects. There's many different types of energy that are also associated here. We have electrical energy, there's sound energy, thermal energy, chemical energy, and by chemical energy, I'm talking like chemical potential, nuclear potential energy, and we could go on. The list goes on and on and on. Now, just to remind you that we are going to focus on mechanical energy only in this particular class. And again, the first three types: kinetic, gravitational, and elastic. So let's do a quick overview of these three types of energy. The first type is kinetic energy, and as you can see here, the kinetic energy is 1/2 times mass times velocity squared. All energy is measured in joules, and the way I like to do this, again, you won't see this in all textbooks, but I like to use an E for energy, and then the subscript denotes what type of energy I'm dealing with. Notice here the subscript K would indicate that it is kinetic energy. The next type is gravitational potential energy, and basically this is mass times gravity times height, and by height here we're referencing some level that we define as our zero height. Typically we call this the ground, but again, that could be any level that we really define. It's sometimes what's convenient in a problem. Then the last type that we calculate in this particular class is elastic potential energy. This is just a fancy way to say that something that stretches and is springy, like a rubber band or elastic, or like a spring in particular. We deal a lot with the springs. Basically, it stores energy in it that way. So specifically, the type of energy we have here, this equation, is elastic potential energy, but it's specific for springs. That's why the subscript is an S. K is something called the spring constant, and X is the distance we stretch our spring from its resting, what we might call its equilibrium position. And lastly, in this class we don't deal with it, but I'll mention it at least. There's rotational energy, which has to do with how things spin and how fast they go. So again, I'm not going to say too much more other than this equation right here on the side here. This is kind of like mass for rotational, and this is rotational speed. So if you think about this equation, this is very much like our kinetic energy equation up here, where it's 1/2 times mass times velocity squared.